This lesson is on applying the Pythagorean theorem. First, we need to recall what the theorem is. It is a squared plus b squared equals c squared, where a and b are the legs of my right triangle and c is the hypotenuse. Remember, this only works for right triangles. So my first example says a triangle has a hypotenuse of length 10 and one leg with a length of 3. What is the length of the other leg? So I plug these numbers into my theorem, and I have 3 squared plus b squared equals 10 squared. I simplify, and I have 9 plus b squared equals 100. Subtract 9 from both sides. They cancel on the left, and I end up with b squared equals 91. I take the square root of both sides. 91 does split up into 7 and 13, but I do not have a pair of numbers to pull out, so that just stays square root of 91. And my final answer for the other leg is b equals square root of 91. My second example says, a 15-foot ladder leans against a wall. If the base of the ladder is 8 feet from the wall, how far up the wall is the top of the ladder? State your answer to the nearest tenth of a foot. So we have some important information here. So I have 15-foot ladder. The base of the ladder is 8 feet from the wall. And there is the wall that I drew. So I draw on my ladder. The ladder is 15 feet and its base is 8 feet from the wall. I'm looking for how high up the wall the ladder goes, so that would be h. So I plug this into my theorem. H squared plus 8 squared equals 15 squared. Simplify and I get h squared plus 64 equals 225. Subtract 64 from both sides, and I get h squared equals 161. Then I take the square root, and h equals 12.7 feet because I wanted my answer rounded to the tenth of a foot, the nearest tenth of a foot. Now my next example, we talk about Pythagorean triples. All Pythagorean triples is they are a set of integers that satisfy the Pythagorean theorem. So you could put 3 squared plus 4 squared, that will equal 5 squared. 5 squared plus 12 squared, that will equal 13 squared, and so on. Okay? So if I want to make a new Pythagorean triple formed with the side lengths 9, 12, and 15, if you look at this chart, if I take 3, 4, and 5 and multiply by 2, that gives me 6, 8, 10. If I take 3, 4, 5 and multiply by 3, that gives me 9, 12, 15. So these are all just multiples of each other. So if I start with 9, 12, and 15, I want to find two other sets. The first set, I'm just going to multiply by 2. So 9 times 2 is 18, 12 times 2 is 24, 15 times 2 is 30. There's my first set. I'm then going to take my original set and multiply by 3. So 9 times 3 is 27, 12 times 3 is 36, 15 times 3 is 45. There's my second set. So you can take your given set and multiply by any number. As long as you multiply every number by that number, you'll have a new set that will satisfy this equation. There's a couple of you try now problems, so I'd like you to pause the video before trying so you can double check your answer. This problem says an isosceles triangle has a base measuring 24 meters and two congruent sides, each measure 15 meters. Find the area of the triangle to the nearest square meter. I have my area formula that I put in a rectangle. We will need that. Now I drew an isosceles triangle with a base of 24 and the congruent sides of 15. In order to use that area formula, which is 1/2 the base times the height, we need to find the height. So in order to do that, I'm going to draw a perpendicular line from the top of my triangle to the base. Okay, notice it does not touch the congruent sides. It bisects the base of my triangle. So that splits the base up into 12 and 12, and I'm looking for the height. So now I can use this right triangle here for Pythagorean theorem so I can figure out the height of my triangle. So 8 squared plus 12 squared equals 15 squared. Simplify, 8 squared equals 144 plus 225. Subtract 144 from both sides, it will cancel on the left. I have h squared equals 81. Take the square root, so the height is 9. I can now plug that into my area formula. So I have area equals 1/2 times the base, which is 24. We want to make sure we use the whole base measurement and not just half, which would be 12. Times the height, which is 9. Simplify, and that gives me 108 meters squared. Okay, so I know there was a lot to this problem, but when you have this isosceles triangle, we just need to draw that line down the middle and use Pythagorean theorem to find the height, and then we just use the area formula. And that is my final answer. Again, I'd like you to pause the video to try this on your own, and then you can play it again so we can go through it together. So number 2 says a right triangle has 2 legs, one with length 5 inches and the other with length 6. What is the perimeter of the triangle? So first I'm going to draw this out. In order to find the perimeter here, I need to find the hypotenuse. Because it's a right triangle, I can use Pythagorean theorem. So I have 5 squared plus 6 squared equals 8 squared. For hypotenuse, you can use C as well if you'd like. So I have 25 plus 36 equals h squared, which gives me 61 equals h squared, and I square root both sides. I can't take the square root of 61, so I'm going to use the decimal, which is 7.81. And to find perimeter there, I have the equation, which is just adding all the side lengths together. So you can see I plugged those in there. So the perimeter is 18.81 inches. And that is my final answer. Now for this final problem, it says find 2 other sets of Pythagorean triples using the given sides of a triangle, 16, 30, and 34. There are many different solutions to this problem. All you have to do is take 16, 30, and 34 and multiply all 3 numbers by any number you want. You can multiply by 2, multiply by 3, you can multiply by 325 if you want, as long as you multiply every number by the same number. If you'd like to double check these answers with me, you may do that the next time we have class.